Welcome back to section 8.3. We're picking up where we left off with the introducing trigonometry. In our first part of our video, we talked about what is a trigonometric ratio, sine, cosine, and tangent. So we talked about the differences of those, how to solve them. Now we're going to apply it to a real world situation. Now here we have the Leaning Tower of Pisa, and one of the first things you'll notice, number one, these are I think these are accurate dimensions. Number two, if we were to draw a triangle here, and as you can see, a triangle has been drawn, okay, and it's 90 degrees because we're assuming that, well, not assuming, but to measure a vertical distance, you go straight up and down, perpendicular from the earth. So it's a right triangle. Now notice that this is not an automatic triangle. It's not a 45, 45, 90. It's not a 30, 60, 90. And we don't have two sides of the triangle. So if we're trying to find this missing length, L, here, then we cannot use the Pythagorean theorem. So what do? Well, we use, not Pythagorean theorem, we use trigonometric ratios to help solve. That's sine, cosine, and tangent. Now, long ago, mathematicians determined that the ratios of these sides, remember that sine, cosine, and tangent are all ratios. The ratios of particular angles are going to be the same no matter the size of the triangle. So if we have a triangle with a 5-degree angle right here, okay, so 5 degrees. If this is only 2 feet, this is going to have the same proportion of sides, okay, as this one with a 150-foot side. So they're similar triangles. If they have two angles that are the same, then they're similar triangles, and the ratios are going to be the same for those two triangles. So using that information, we can solve this problem. We can find the missing length even though we only have one side and one angle, okay? Well, technically two angles because it's a right triangle. Well, technically three angles because you can find, you get the point. So if you have an angle, in addition to the 90-degree angle and one side, you can solve for all the other sides of the triangle. Now, how do we start? Well, it's very similar to what we did up here. The first thing we want to do is determine the reference angle. So we're going to determine our reference angle, and it's clearly going to be this one because that's the one it gives us that's in addition to our 90-degree angle. So this is our reference angle. If you remember from last video, once we have our reference angle, now we can label the sides. So we can label this one the hypotenuse. The hypotenuse is always going to be the same no matter the reference angle because it's opposite the 90-degree angle. Here we have our opposite side because it's the side that's not touching the reference angle. And then this is our adjacent side because it is forming the angle with our hypotenuse. This side is next to, adjacent to, our reference angle. So we have our sides labeled. Okay, so that's step one. So we can go ahead and come up with these steps over here. Step one, reference angle. Step two would be label. And then step three is going to be determine trig ratio. Now, what does this mean? Before we said use trig ratio because it was telling us to use sine, cosine, tangent. Now we don't know which one we have to use, so we have to figure it out. How to determine which trig ratio you're going to use is based on what information it gives you. So if we look here, for example, at our adjacent side, it gives us a measurement. It gives us 150 feet, so therefore we're going to be using our adjacent side. Let's look at our opposite side. Our opposite side has no information, okay? Nor do we want to find the missing length for the opposite side. It doesn't ask us to find the opposite side, so we do not care about the opposite side. Okay, keep that in mind. And now, what are we trying to find? We're trying to find the hypotenuse. Here's the hypotenuse. So we want to find that missing length, L. So hypotenuse and adjacent are the ones we care about. Now we just say, okay, if we're trying to determine the trig ratio, we need to know which trig ratio uses adjacent and hypotenuse. Let's scroll up here. Adjacent and hypotenuse. Sine uses opposite. We don't have opposite. We can't use sine. So this one is out. Okay. Tangent uses opposite again. Can't use tangent. Adjacent is what we're looking for. No, hypotenuse is what we're looking for. Adjacent is what we're given. We're going to be using cosine because of this. So now we've determined our trig ratio. We want to use cosine. So let's go ahead and get my green out. We want to use cosine. Now, one thing you might see a lot is you might see this symbol here. Theta is what it's pronounced. This always, well, almost always refers to an angle. Okay, an unknown angle. Unknown. Okay, so the cosine of an angle, we know, is adjacent over hypotenuse. So I like always setting up my ratio first. Cosine of an angle is equal to adjacent over hypotenuse. Okay, now, what do we want to take the cosine of? Well, we want to put, this is our reference angle here. Okay, this is our reference angle. So that's what we're going to plug in, reference angle. So we're going to say, okay, not cosine of any angle. We want the cosine of 5, specifically 5 degrees. Okay, not 5 radians. That's important. On your calculator, it's going to be 5 degrees. Now we're going to plug in some other information. We know our, sorry, I just want to draw this bar. We know our adjacent side is 150, so we're going to put that in there. And we know our hypotenuse is L, so we're going to draw that in there. So now we have an equation, essentially. What I like to do, and this is optional, but I think it's much more simple than other ways, is I always put the cosine of 5 over 1. Okay, I always put it into a fraction, because if we have a fraction on the right and a fraction on the left, it'll be a little bit easier to cross multiply, in my opinion. Okay. Now, what I need to do here is cosine of 5. How do I determine that? This is where I use a calculator. So I'm going to go ahead and use a calculator. Okay, that's what a calculator looks like, in case you didn't know. Okay, I'm going to use a calculator, and I'm going to compute this in, making sure my calculator is in radians, or sorry, degrees, I misspoke. Okay, and you can check by going into, I think, your mode on your calculator. It all depends on what kind of calculator you're using. I'm pretty sure it's mode. So I checked, and I am in radians at the moment by going into mode, and you want to make sure you're in degrees. Okay, the mode button, and you want to be in degrees. So once I do this, I go cosine of 5. See, my answer is going to change now. Okay, and I get 0.996. And I have a longer decimal. I just rounded it to the nearest thousandths right there. But I'm going to keep it stored on my calculator. Okay, and I'm going to use it later. So I have that over 1 after I inputted it. Okay, actually I'm going to change this to purple, just to show you I only did that for that thing. And this is equal to 150 over L. Now what do I do from here? This is where I cross multiply. So I'm going to cross multiply here. I get 150 times 1 equals 0.996, and it's actually longer, times L. So I need to divide by 0.996, it's actually longer, to both sides. 150 times 1 is just 1. I'm going to leave that there though, actually. So now I just do 150 divided by, and I keep it stored, and I just hit enter, and I get 150.573. If I were to round to the nearest thousandth, equals L. I'm going to round to the hundredth here, 150.57 equals L. And what are the units? The units are feet. So feet. So it's just a little bit longer than it is high. If it's 150.57, it's only 0.57 feet, an extra half a foot or so longer than it is tall. So it's really not leaning that much. So that's how you do it, okay? I probably didn't put a step 4 in there. Step 4, you set up ratio and cross multiply. And then the last step is solve. Step 5 is solve. Okay, so that's your steps to solving this problem. This will work with any problem. Okay, just make sure you label, stick to your sides. Probably the toughest part is determining which one it is. You need to go based on this chart. If you have the opposite hypotenuse, you'd want to use sine. If you have opposite and adjacent, you want to use tangent, cosine, adjacent, and hypotenuse. Hope you found this helpful. Make sure to leave a comment if you want any other videos covered. And join us next time as we talk about inverse trigonometry. Thanks for watching.